Imagine a shoelace, one that you tie every day, perhaps without giving it much thought. At each end of that shoelace is a tiny plastic tip called an aglet, which keeps the fibers from fraying and unraveling. Without those plastic caps, the lace would eventually become so worn and tangled that it would be unusable. In many ways, telomeres in our DNA serve the exact same purpose. They're not made of plastic, of course, but of repetitive sequences of DNA that act like those aglets, protecting the ends of our chromosomes from damage as our cells divide over time. This simple image, the plastic tip of a shoelace, opens a doorway into understanding one of the most fascinating and essential elements of human biology: how our cells maintain order, stability, and function over the course of a lifetime. Every cell in the body contains chromosomes, tightly coiled structures of DNA that carry the genetic instructions for building and maintaining our bodies. At the very tips of these chromosomes are telomeres, and while they don't code for proteins themselves, their presence is vital. Each time a cell divides, it has to copy its DNA, but the copying machinery can't quite reach the very end of each strand. As a result, a tiny piece of the telomere is lost with every cell division. In the early years of life, this loss isn't much of a problem. Our cells still have plenty of telomere length to spare, and our bodies are efficient at repair. But over time, as the protective caps shorten more and more, they lose their ability to shield the chromosomes, and cells begin to age, stop functioning properly, or die. That's why telomeres are often considered a kind of internal clock, not a countdown to catastrophe, but a marker of how many healthy replications a cell has left in its lifespan. This shoelace analogy helps demystify a concept that might otherwise feel abstract or overly technical. Telomeres are often spoken of in terms of base pairs and enzyme activity, but when we think of them as physical structures meant to guard against wear and tear, the story becomes clearer. Just as frayed shoelaces become harder to tie and eventually unusable, frayed chromosomes, or rather, chromosomes with critically short telomeres, lose their stability and increase the risk of dysfunction. This dysfunction can manifest as a wide array of issues: slower tissue repair, decreased immune surveillance, and increased likelihood of chronic disease. It's not an instant collapse, but a gradual, cellular-level erosion that parallels the aging process itself. But there's a hopeful angle here, too. The beauty of the shoelace metaphor is that it doesn't only describe deterioration, it also suggests that protective measures can make a difference. Just as you might replace or reinforce the plastic tips on your shoelaces to extend their life, scientists are discovering ways that lifestyle choices and nutritional support can help preserve or even lengthen telomeres. Habits like regular physical activity, a diet rich in antioxidants and anti-inflammatory nutrients, stress reduction, quality sleep, and the avoidance of smoking have all been associated with longer telomeres or a slower rate of shortening. Among these, nutrients like vitamin D are particularly interesting because of their emerging role in cellular maintenance, DNA repair, and inflammation control, all factors that contribute directly to telomere integrity. What's especially compelling about this perspective is that it puts a powerful, abstract biological process into a framework of action and understanding. We can't stop the clock of aging, but we can influence how fast or slow it ticks. Protecting our telomeres, in this light, becomes not just a matter of biology but a daily, tangible choice, much like choosing not to drag your shoelaces through the mud or tie them too tightly. It's a reminder that aging isn't just something that happens to us, but something that reflects how well we care for our own internal structures. So the next time you look down at your shoes, consider the story of the telomeres, the tiny guardians of our chromosomes that do so much more than we see. Like the aglets on your laces, they seem small and easily overlooked, but they are crucial to the durability, function, and integrity of everything they're attached to. In understanding this metaphor, we not only grasp a powerful scientific truth, but also gain a bit more clarity and hope in the quest to age well, stay healthy, and preserve the cellular fabric of life.